Hello everyone, my name is Arpitra. So today we are going to discuss about unit number 5, coding and testing, lecture number 39. So let us go through the contents that we are going to discuss in this video. We are going to discuss about programming principles and guidelines, structured programming, and information ID, and some programming practices. So let us see what is structured programming. So structured programming is also called as go-to-less programming. So although use of go-to statements is not desired in any programs, structured programming allows occasional use of go-to statements. Now a program consists of two types of structure. Okay, so there are static structure as well as dynamic structure. Now the actual statement in the program forms the static structure, and the statements that get executed during the execution of the program form a dynamic structure. So whatever we write the program, that is the static structure, and the program statements that gets executed, which are getting executed during the execution of program, form a dynamic structure. So static structure remains fixed while the dynamic structure varies, as the name suggests. The goal of structured programming is to create similar static and dynamic structures, and objective of the structured programming is to write the program such that sequence of statement executed is the same as the sequence of statements executed in the source code of the program. Now in static structure, the programming statements are linear organized. So the control of the flow of statements during the execution must be linear, that is during the sequence wise. The key property of structured programming is it has single entry and single exit statements. So as I discussed, structured programming is linear, so it will be having single entry and single exit structures. So execution of the program starts at one specific point and terminates at another specific point. Now this makes the property similar dynamic and static structure in the structured programming. Now most commonly used single entry and single exit statements are sequencing, that is statement 1 and statement 2 was written up to statement 10. Second one is selection statements. Now it is a single entry and single exit statements. If condition, then statement 1, else statement 2. Okay, if condition, then statement. So this if else statement is an selection, it is a single exit and single entry statements. Third one is iteration, that is while condition, do statement, do while loop. So in structured programming, these three structures are sufficient to adopt any algorithm and help them to keep the control flow linear. So this is how structured programming practice forms a good basis and guidelines for writing the programming. Now let us see what is information hiding. Now data structures used in the program capture all the information required in the program from level. So whatever the program we write, we use some of the data structures that capture all the information required. Now certain operation can be performed in the data structure in order to share that information. So the programs perform some operation on the data structures. For example, consider a stack data structure on which we perform various operations such as pushing the elements of the stack, popping the elements from the stack, and checking whether stack is empty or full. So using this operation only, some information get shared present in the problem and domain. Now when the information is captured by the data structure, some SS function should be provided in order to assess that information. Okay, so but due to the information hiding technique, so the information hiding technique, what it does is there is a restriction on SS function to assess the particular information. So we are using a stack, so whatever elements we are pushing and popping should be accessible. So many older languages, C, Pascal and Fortran, do not allow the concept of information hiding. That is, it does not allow information to get hidden. But modern languages such as C++ and Java support information hiding. Now some programming practices which are used here is, first one is control constructs. So it is desirable to use a single entry and single exit constructs as much as possible. So this is also desirable for good programming practices. Second one, go-tos. So go-to should be used sparingly and in a disciplined manner. Suppose if the go-to must be used forward transfer is more acceptable than a backward jump. Then you have information ID. So information ID, as I repeated in the previous slide, it should be supported wherever possible. So access functions to the dash should be made visible, where hiding the data structure will be behind the functions. Fourth one is nesting. So nesting of if then else becomes too deep, then the logic becomes harder to understand. So we must use if else statements wherever it less as possible. So proper nesting or more nesting should not be done, or more deep nesting should not be done, because it will be difficult to understand the code. So deep nesting should be avoided. Model size. So a programming should carefully examine any function with too many statements. Whenever you write a function, it should contain not more statements, hence larger models will not function cohesive. Model interface. So a model with complex interface should be carefully examined. Any model whose interface has more than 5 parameters should be carefully examined and broken into multiple models. So if a model says has 5 parameters, we can break the single model into multiple models. Seventh one is side effects. So when a model is invoked, it sometimes has side effects of modifying the program states. For example, modifying global value. So such side effects should be avoided wherever possible. Eighth one is robustness. That is, a program is robust if it does something planned even for exceptional conditions. So a program might encounter an exceptional condition in such forms, so the incorrect value of some variable and overflow. In switch case with default. So if there is no default case in switch frame, the behavior can be unpredictable, because default case should compulsory be there. So if that case arises at some point of time which was not predictable at development stage, so switch cases when we are using default case be compulsory be included. Such a practice can result like a bug like null difference, memory leak, as well as other types of serious bugs where we don't have default case in switch. 10th one is empty catch block. So an exception is caught, but if there is no action, suppose here there is an exception but there is no one to caught it, so it may represent a scenario where some of the operation can be done are not performed. So wherever exceptions are caught, it is a good practice to take some default action, even if it is just printing an error message. So 11th one is empty if while statement. Now a condition is checked but nothing is done based on the check. So this occurs due to some mistake and should be caught. We should not use any empty if statement. If it does not does anything, there is no use of using that if statement. Read return to be checked. So the return value what we use in the function is not checked, assuming that the read returns the desired values. So sometimes result from the read can be different from what is accepted, so it can cause failures. So return statement should be checked properly. Third one, return from final block. So one should not return from final block as it can create false beliefs. So in this video we have discussed about various programming principles, different programming practices. Thank you.